All right, least common multiple. This is a little different than greatest common factor. They're pretty closely related, but let's talk about how they are different. First of all, just a simple example of what multiples are and factors are. So, for example, if you were to list the factors of 4, well, 1 times 4, those are numbers that you can multiply together and get 4. Again, factors are numbers you multiply together to get that number. Also 2 times 2. So 1, 2, and 4 are the factors of 4. Now if you were asked to list the multiples of 4, you'd start with the number itself, and then you'd add 4, and these can continue on for however long as you want. So notice the difference between factors of a number and the multiples of a number. Now, as we've done before, for the greatest common factor, if I had 10 and say I had 30. Now if I did a factor tree for each, so for 10 I would have 2 times 5. For 30 that breaks down to 5 times 6, and then that can break down to 2 times 3. So I would have 2 times 3 times 5. Now, what's the greatest common factor? Remember, for greatest common factor, they have to be common in both. So what do I have common in both? Well, I have a 2 in both of them, and I also have a 5 in both of them. And I multiply what's common. So my greatest common factor of 10 and 30 is actually 10. 10 is the largest common factor between the two numbers. Now, just for the sake of example, suppose that I change this 2 to a 2 squared. Say that was a 2 squared. Now, what's common for 2's? Remember, you take the smaller exponent. So in other words, here I have 2 to the first, and over here I would have a 2 squared. I take the smaller exponent, it's a 2. 2 is common. So for greatest common factor, all along we've emphasized that you got to take the smaller exponent. Again, I just want to emphasize that. Say that, let me erase these here and give you 2 different factorizations. Say that in one of the factorizations you have 3 times 5, and say in another one I had 3 squared times 5 squared times 7. Now, what's common in both? Well, I have 3's in both. You take the smaller exponent. Times, I have 5's in both. I take the smaller exponent. Do I have a 7 in both? No. So my greatest common factor in this case would be 15. So that is a review of the greatest common factor. Now, let's take a look at example. This would actually be your first example, example 1. I want you to copy this down, leave a little space between the numbers. Now, in this one here, we're going to review the least common multiple. We're going to review what we've already talked about with least common multiple. So the first thing I'm going to do is I'm going to find my factorizations of each of the numbers. So this one would be 2 times 7. For 20, I could use 4 times 5 and then break that down to 2 times 2. So I'd have a 2 squared times 5. And then finally for 30, we just did that a little bit ago. 5 times 6, and 6 breaks down to 2 times 3. So I would have a 2 times 3 times 5. Okay, those are my factorizations. Now, I want to find the least common multiple. Now, as we've talked about before, if they are in more than one of the factorizations, if they're in more than one, you take the larger exponent. So notice that I've got a 2, but I also have a 2 squared, and I have a 2 here. Take the larger exponent for the least common multiple. Now, you have 5's in both. Take the larger exponent. Well, they're both the same, right? Now, a big difference also with least common multiple is you also take what's not in more than one of them. So I've got a 7 that's only in one of them. So I have to take that 7. So the rule is, for least common multiple, if it's in more than one of them, take the larger exponent, and then also take the numbers that are only in one of them, like the 7. So here I would have 4 times 5 times 7, which would be 20 times 7, which would be 140. So the least common multiple of 14, 20, and 30 is 140. So what this means is if I listed the multiples of 14, which would be 14, 28, keep on adding 14, 42, ... For 20, it'd be 20, 40, 60, they keep on going. And for 30, 30, 60, and they keep on going. I would not meet until we got to 140. Now let's do the new stuff. Okay, least common multiple with variables. Okay, least common multiple of algebraic expressions. All right, the first thing we're going to do is find the prime factorizations of the numbers themselves. So 4 is 2 squared. And then 6 would be 2 times 3. All right, let's find the least common multiple. Now the 2's are in more than one of them. They're common, aren't they? Take the larger exponent for the least common multiple. Now you also take what's not in more than one of them, you take the 3. Now let's go to the letters. All right, you have A's, and A's are in more than one of them. You've got an A cubed and an A to the 10th. For least common multiple, you take the larger. You've got the B squared, B to the 4th, take the larger. Now let's simplify. So you have 4 times 3, or in other words, you have 12, A to the 10th, B to the 4th. So 12, A to the 10th, B to the 4th is our least common multiple. All right, last example. Okay, copy this, pause this, and write it down. Okay, let's find the prime factorization of 12. Let's see, I'll start with 2 times 6. That breaks down to 2 times 3. So that would be 2 squared times 3. For 20, I'll use 4 times 5, which breaks down to 2 squared times 5. All right, now, let's find the least common multiple. Now, the 2's are in more than one of them, aren't they? They're the same amount, right? Both of them are 2 squared, so you just have a 2 squared. Now, if one was a 2 cubed and the other was a 2 squared, I take the 2 cubed for the least common multiple. Now, we also take what's not in both of them. So we've got a 3, and we've got a 5, and we're multiplying them together because with least common multiple and greatest common factor, you multiply them together. Now, what do I have for letters? Let's see, x to the 4th, x to the 6th. Well, it's x to the 6th. How about the y's? Y squared, y to the 1st. Take the larger exponent. And then the m cubes are both m cubes, so it's just a m cubed. So my answer would be, let's see, that's a 4. 4 times 3 is 12. 12 times 5, what is that, 60. X to the 6th, y squared, m cubed. And that is my least common multiple. So the topic of this video is least common multiple of algebraic expressions.